Hello everyone. Today we will start our classes on computational physics. So I will be dealing with the first module, that is the solution to nonlinear equations using different numerical methods. So in scientific and engineering studies, it is a frequently occurring problem in order to find a root of equations which is of the form f of x is equal to 0. So there are different type of equations. A linear equation is the one which relate to a straight line. So if you can express the expression in this format, that is f of x, which is equal to mx plus c, which is representing a straight line, which slope m. And if the function, so this is f of x is the functions, if we are not able to represent in this format, in a straight line format, then we can call this is as a nonlinear equations. So it is often difficult questions how we can solve a nonlinear equations of the form f of x which is equal to 0. So the thing is that sometimes this kind of equation may have just one solution in the case of just like in the case of a linear equations. Sometimes it can have many solutions, or we can have no solutions at all. So for example, we can consider this very simple nonlinear equations where f of x is equal to x square minus 9. So this one we can solve. This one can have two definite solutions. One is plus 3 and other one is minus 3. Whereas this nonlinear equations, that is f of x is equal to x square plus 1, has no solutions at all. So if you can solve this one, you cannot have no solutions at all. So in this kind of things, we need to have some numerical methods in order to approximate the solution, which may not be the exact solution, but it will be a solution which is very close to the exact values. So that's why we had to use different type of numerical methods. So we'll be discussing about two type of numerical methods in this class. One is called the bisection method, and the second one is the Newton-Raphson method. So we'll discuss about each of these methods in detail. The bisection method. So this method is based on the fact that if a function f of x which is continuous between two values a and b, and if f of a and f of b are opposite signs, that is the plus and minus sign, then there exists at least one root which will be between a and b. So this is the basic principle behind these ones. So that means if f of a is negative, so if you substitute a value here, and if f of a is negative and if f of b is positive, then there exists a value which is approximately a plus b by 2, which will be in between a and b. If this the new root, the new value a plus b by 2, if it is the exact root, then f of x0, that the new root we can call x0 a plus b by 2, which can be then f of x0 should be equal to 0. If it is not the exact root, then we again we need to find out the value of f of x0. If it is a positive value, then means the root will be between f of a and f of x0, and if f of x0 is a negative value, then it will be the root will be between x0 and b. So this is how we estimate the root of the equation f of x using the bisection method. So here is the procedure to find out the root using the bisection method. So first we choose two real numbers a and b such that the f of a into f of b is which is a negative value. The product of these two will be a negative value. Then the approximate root xr is equal to a plus b by 2. If xr is the exact root, then f of xr is equal to 0. Then we can stop there. And if f of xr is not equal to 0, and if f of a into f of xr is negative value, then the root lies between f of a the a and xr, the value between a and xr, because uh, f of a is a positive. f of a is positive and f of xr is negative. So always the root will be between this positive and negative. Then we set the new b value as xr. Suppose f of xr is a positive quantity, then f of a into f of xr is greater than 0. Then the new root will be lies between xr and b. So then we substitute a is equal to xr and we go to the next steps. If f of a into f of xr is equal to 0, that means the f of xr is equal to 0, that is xr is the exact root of the equations. So in practical problems, the root may not be the exact, so that we had to do a lot of steps to find out the estimated. Finally, we had to estimate the root of the equations. So we can calculate the percentage error based on this one. If xr dash is the new root and xr is the previous value, then xr dash minus xr divided by xr dash into 100, that will be the error percentage in your final value. So always when you ask to do this problem, they will ask you to do this. Your error should be about this much error. You can have this much error. So this is how you estimate the final root of the equation. You will get to know about this one using some examples. So this is the first one. You are asked to find out the root of the equation, which is x cube plus 4x square minus 1 equal to 0. So what we do is we substitute some values. So let a is equal to 0. If you substitute a is equal to 0 here, then f of 0 will be 0 plus it will be minus 1. So this is a negative quantity. Then we substitute x is equal to 1. So that is b is equal to 1. So this is 1 plus 4, 5 minus 1, 4. So this is a positive quantity. So the root of this equation will be lies between these values, that is 0 and 1. So the root will be between these two values. So the first approximation is that we make xc is equal to, which is average of these two, that is 0 plus 1 by 2, that is 0.5. Now we calculate what is f of this value, that is f of 0.5. So you substitute 0.5 here, then you will get f of 0.5 is 0.125. See, this one is a positive quantity. Now this f of 0.5 and f of a, that is f of 0, are opposite sign. So now the root will be between this 0.5 and 0. Now we take average of this value, that is the new xc, that is 0 plus 0.5 by 2, that is 0.125. Again we substitute x is equal to 0.125 here, and we see what is the sign of this one, and we continue this way, and we can finally estimate the approximate root of this equation. So this is another problem. So here you are asked to do to find out the solution of these equations, the nonlinear equation f of x is equal to x cube minus x minus 1 equal to 0. So as we did earlier, we substitute, we estimate, let a value, let it be 1. So if you substitute 1 here, it will be 1 minus 1 minus 1. So it's a negative value. And if substitute for 2 here, f of 2 is a positive value. That means the root will be between 1 and 2. Then you take average of that, that is the new root, that x0, this is 1.5. Then you substitute for x0 in this expression, that is f of x0, that is a positive quantity. So that means the new root will be between this x0, that is 1.5 and 1, because f of 1 is negative and f of 1.5 is positive. So the new root is x1 is this average of these two, that is 1.25. Now you substitute for x1 is equal to 1.25 here. So you'll get a negative quantity. Now you got a negative quantity. That means the root is between which values, that is between f of between 1.25, 1.25 is and f of 1.5 is positive. So the new root is between this 1.25 and 1.5. So x2, we take average of these two quantity, so that is 1.5. 375. So the root is f 1.375. Now we substitute x value as x2, that is 1.375, and we repeat this one, and based on the successive approximation you can do this calculation. You will get the new x value, that is x3 is equal to 1.3125, x4 is equal to 1.34375, x5 is equal to 1.328125, and so on. Now, there is another problem. You are asked to find out the root of this equation, that is x cube minus 2x minus 5. Now again we approximate the x0, that is a value as 2, and f of 2 is minus 1, and b value as 3, that is f of 3 is 16. So you just try it out. We can substitute 1 first, then you substitute for 2, and so on. So the since this value is minus and this value is plus, the new root will be, the root of this equation will be between this 2 and 3. Now x1 is 2 plus 3 by 2, that is 2.5. Then substitute for x1 here. Then f of x1 is a positive quantity. So that means the root will be between 2.5 and 2, because f of 2 is negative and f of 2.5 is positive. The root will be between these two values. Substitute here f of x2, and you can see that this is a positive quantity. So the root will be between 2 and 2.25, because f of 2 is negative and this value is positive, and you will get x3. And since f of x3 is this one, again this is a positive and f of 2 is negative, the root will be between these two values. You continue these calculations, you will get x4, x5, x6, etc., and finally this is x11. And the error percentage, we can see that that is the separation between the nearby values x11 and x10, that is only 0.0005. So that means it is percentage value is divided by x11 into 100, that is 0.02 percentage. So here the root will be correct till the third digits, 3 decimal points. So the we can finish here, because the 2.094 until the third decimal point, the root value is same for x10 and x11. So we can stop calculation here, and we can estimate the root of this equation as 2.094, correct to the 3 decimal places. Now the next question is to find the positive root between 0 and 0.1. The equation is x equal to e raised to minus x to a tolerance level of 0.05 percentage. So this equation you can rewrite as x into e raised to x minus 1 is equal to 0. So f of 0 is, we substitute x is equal to 0 here, it is a minus 1, and if you take f of 1, it is a positive quantity, e is 2 point something, right? So it is a positive quantity. So the root will be between 0 and 1. So x1 is 0 plus 1 by 2. So f of x1 is f of this word, f of 0.5, it is a negative quantity. So that means the root will be between 0.5 and 1. So you take average of that, and you calculate the tolerance level, that is x2 minus x1 by x2 percentage. So the error percentage, that is 33 percentage. So you need to have the error percentage of 0.05 percentage. That means you need to continue do the calculations. So the new x2 is average of that. So f of x2 is positive. So the root will be between 0.5 and 0.75. So x3 is 0.5 plus 0.75 by 2, 0.625. Again calculate the tolerance level. The percentage value is 20 percentage. You do the calculations. So the x4 is this value. The corresponding percentage value is this. X5, x6, and so on. Finally, when you take the x11, that is 0.035 percentage, which is less than 0.05 percentage. So you can stop do calculation here, and the corresponding x11, which is the root of these equations, that is 0.567. Here is another problem to find the root of the equation x cube plus 4x square minus 1. So you can try it out these equations. So this is we take initially a is equal to 0 and b is equal to 1, and you can continue this calculation, and finally you can approach this value. This is for you to work out, and here are two assignments for you to submit within a week time. uh, so finally we can conclude the bisection method, which is a simple and easy to implement, is a one function evaluation per iterations. There is no knowledge of derivatives needed if you want to calculate the bisection method. The drawback of this method is that we need to have two initial guesses. So we need to guess the values of a and b, which brackets the root. So it's not very easy to guess these values for some uh, equations, some nonlinear equations. Uh, because of this, we need to have a lot of iteration steps, and so it is a slowest method to converge to the solutions. So when the interval contains more than one root, the bisection method can find only one of them. So in all these problems, there was only one root of the equations. If it has two roots, if the equation is having two roots, we can only find one root out of those two roots using the bisection methods. Now we move on to the second method, which we are going to discuss here, that is the Newton-Raphson method. The Newton-Raphson method is much more efficient method than the bisection and some other iteration methods. So here we approximate that if x is the real root and x0 is the initial approximation of the real root of the equation f of x is equal to 0, then f dash x0, which represents the slope of the point at x equal to x0, which is not equal to 0, then f of x has same sign between x0 and x. Then the tangent, that is the f of x0, tangent at the f of x0, which will lead to the real root x. So you will clear here, let x0, which is the approximate root of the f of x, this function is the f of x, this function, and let x0 be the approximate root of this one, the equations, and this is our initial guess, x0 is the root of these equations. Then f of x equal to 0. If x is the real root, if x1 is the correct real root of this equation, then f of x1 should be equal to 0. Then this x1, which is equal to x0 plus h, so that f of x1 is equal to 0. So this f of x0, f of x1 is equal to 0, where x1 is x0 plus h. So you can expand this one using the Taylor series. So f of x0 plus h, if you expand this one, this will be f of x0 plus h f dash x0 plus h square by 2 factorial f double dash x0 plus etc., which is equal to 0. So now we neglect all the higher order derivatives, that is the second and higher order derivatives, so that this expression becomes f of x0 plus h f dash x0 is equal to 0. From this we can find out what is h, which is minus of f of x0 by f dash x0. So x1, the real root of this equation is x1, which is x0 plus h. So that will be x0 minus f of x0 by f dash x0. So this a better approximation of x0, which is x1, is equal to x0 plus h, which is x0 minus f of x0 by f dash x0. So this is the better approximation. So you need to calculate higher order values, that is x2, which is some x1 plus h, and x3, xn, and so on, and finally the xn plus 1. So in general we can write xn plus 1 is equal to xn minus f of xn by f dash xn. So this formula will be used for solving the nonlinear equation using the Newton-Raphson method. Now you can find the root of this equation, that is x square minus 4x minus 7 is equal to 0 near the point x is equal to 5 to the nearest thousandth. So that means here the initial guess x0 is 5. So you can take x0 as 5, and you can take first f of x is x square minus 4x minus 7, and the first derivative of that is 2x minus 4. Now we use this standard equation, that is xn plus 1 is equal to xn minus f of xn by f dash xn. So that means x1 is equal to x0 minus this one f of x0 by f dash x0. So f of x0 means f of 5 will be this value. You substitute for 5 here, and f dash x0 is f dash 5, that is 2 into 5 minus 4. So you will get this value x1 as 5.33. Now x2, which is this value, that is x2 is x1 minus f of x1 divided by f dash x1, and here you will get this value. Then x3 is equal to x2 minus f of x2 by f dash x2, and this value is 5.3166. Here if you compare these two values, you can see that it is until the third decimal point these two values are same. So that means our answer is correct till third decimal point. So this we can stop calculation here, and the final value of this final answer is 5.317 if you make it to the 3 decimal places. Here is another equations, that is f of x is x cube minus 2x minus 5. Then f dash x is 3x square minus 2. So this is the general format, that is xn plus 1 is equal to xn minus f of xn divided by f dash xn. So here you need to have a initial guess, that is the value which is close to the real root, that is x0. We take the x0 is equal to 2. So that the f of x0 is here, if you substitute 2 here, you will get it is minus 1, and f dash x0 you will get 10 plus 10. Then x1 is x0 minus f of x0 by f dash x0, which is equal to 2.1. Now you take f of x1 and it will be 0.061, and f dash x1, substitute x equal to 2.1 here, you will get it is 11.23. Now x2 is x1 minus f of x1 by f dash x1, it is 2.0945, which is the root of these equations. Here is another equation for you to work out. The f of x is x sinus plus cos x. Then f dash x is x cos x. Here you can have the initial guess value, that is x is pi, that is 3.14. Then you can get higher order values, and finally you can arrive at the root of the equation, which is 2.798. This is another one, is also for you to work out. The function is x cube plus 4x square minus 1. Then f dash x is 3x square plus 4 2x minus for 2x. Then you can calculate the x1, x2, x3, x4, and we can finally arrive at the root of this equation. So I will explain once more about this method here in the Newton-Raphson method. First you will have an initial guess, the x1, x0 value. Then the root which is close to the real root is x1, which can be obtained from by drawing a tangent at this point. So that is the method here. You draw a tangent here, and it will intersect at x axis at x1, which is x1 is equal to x0 plus h, which is close to the real root. Then at this point at x1 value, you take another tangent which will be intersecting at another point here, which is x2, and finally you can arrive at the root of this equation. So this is how we do the calculations in using the Newton-Raphson formula. These two are assignment for you to submit within a week time. So as you discussed earlier, Newton-Raphson method is much more efficient than some other method like bisection method, but it also got certain drawbacks. The first one is we need to have the calculation of the derivative of the function, which is not always easy. And the second thing is the f dash, the derivative of the function at x value, that is if it vanishes, that means if it is equal to 0, then the method will fail to converge. So you cannot get the answer. The third one is if the step is too large, if you are taking x value, if it is too large, or the value, the final value is an oscillating function, then this method is not the correct one. Okay, we'll stop here. Thank you.